Okay, so you can see here, just at the top of the screen there, we've got our basic exponential graph. So if you compare 2 to the x and 10 to the x, there's not a real lot of difference, okay? You can just see how the 10 to the x graph gets a lot steeper, a lot quicker, but it also approaches 0 a lot quicker, all right? And it makes sense. 2 to the power of 1 is only 2, but 10 to the power of 1 is 10. 10 to the 2 is 100. 2 to the 2 is only 4. So the same basic shape is there. Y-intercept is there, horizontal asymptote, etc. The only thing that changes is the steepness of the graph. The previous page summarised all of our transformations that take place depending upon the graph that we have, I guess. So you can see there we've got 3 different 2 to the x graphs. If we have a look at A, we've got a negative sign up there, so that's a reflection. So that's about the y-axis, isn't it? So that graph is just going to be something like that, and again, still going through 0, 1, okay? Negative 2x, okay, so the negative out the front reflects a graph about the x-axis. So again, it's just that image gets reflected and the y value gets multiplied by a negative 1. So we got that way. And then for question C, we've got a little bit of both. We reflect it down, and then we have to reflect across. So if you like, we reflect across, and then we reflect it down. We have that graph there. And again, that point, 0, negative 1. So it's just being aware of what your basic shape is, and then applying the transformations that take place. A bit more, 2 to the x plus 1. So again, if I put an axis in, and that plus 1 I know shifts everything up, so I might just have my original graph. Plus 1 moves the horizontal asymptote up 1 unit, so that's the line y equals 1. The negative x reflects about the about the y-axis. So the intercept, which is normally at 0, 1, has been moved up 1 unit, so it's now at 0, 2, and my graph goes the other direction. Yeah. What's the next question asking us about? Minus 1, it goes down, so I might move my horizontal axis up higher. That's x equal to 0, y equal to 0, etc. So what's going to happen, we've got a negative sign out the front, which makes everything upside down. So if I just do a light graph, so the negative sign out the front, so that's just negative 2 to the x. And now I want to move everything down 1 unit. So that point there, my horizontal asymptote comes down 1 unit. So that's now the line y equals negative 1. And my line goes through something like that. Okay, and the point 0, negative 2. Sketch the graph of 2 to the x minus 1 minus 2. Again, so what's going to happen here? It's going to come down. The negative 1 in there. So let's do my axis here. Sorry, y equals 0. Let's just notice that little mistake up there. Let's just call it the x-axis. Whoops. Let's just call it the x-axis and the y-axis. Sorry about that. So I'll just call it the x-axis, the y-axis. So my standard graph, if I just do my standard graph, would normally go through the point 0, 1. Negative 1 inside moves it all across 1 unit. And the negative 2 down moves everything down 2 units. So that's my new point. My horizontal asymptote I know goes down 2 units. So there's y equals negative 2. And that's it really. So let's just check the y-intercept. So it's just to see where I go. So if I y at x equal to 0, y is equal to 2 to the minus 1 minus 2. Don't forget 2 to the minus a half. Minus 1 is a half. So negative 3 on 2. So there's my y-intercept there. And my graph will go up there through that. Showing the intercepts and asymptotes, stating the domain and range. Oh, geez, I didn't even read the question. We'll go back and do all the domain and ranges. So we've got our y-intercept. Let's get our x-intercept. I'll put y equal to 0. I'll get 0 equals 2 to the x minus 1 minus 2. Take the 2 across. Okay, now in actual fact, we can just, because the bases are the same, we can just equate the powers, or we could do our log transformation, which we'll talk about later on. So we get 1 is equal to x minus 1, so x is equal to 2, which fortunately enough, I put through there. Finally, the domain of my graph, x values is R. The range of my graph is from -2, not inclusive, to positive infinity, yeah? Let's come back up in here. The domain of my graph is again R. The range, which one are we focusing on? The green graph. The range is from -infinity to, what's that value? -1. Don't forget, the smallest number goes first. The domain of the first graph is again R. The range is from, or +1 up to infinity. Notice all the round brackets in there, yeah? All right, first things first, shovel workings. I won't do the CAS calculator stuff. Sketch the graph file showing intercepts and asymptotes, state the domain of range. So again, I'm going to put in a, so the 2 is going to move it up. We're going to get reflection. So what if I just put my horizontal axis a bit lower, since everything gets moved up. X-intercept, y-intercept. So I'm just going to rewrite my graph as y equals -3, x minus 1 plus 2. So first things first is I can bring my asymptote up and label it y equals 2. The negative sign out the front makes everything upside down. Okay, so normally a graph, if you like, would look like that. But instead it's moving up, so that point there will come to there, and then the -1 is going to move it to the right 1 unit there. So my graph is going to look a bit like that. Let's check x and y intercepts. If I put x equal to 0, y is equal to -3 to the minus 1 plus 2, which is equal to -1/3 plus 2, which is 5/3, which seems reasonable. 0, 5/3. And we'll go the x-intercept. I'll put y is equal to 0. I get 0 is equal to 2 minus 3 to the x minus 1. 3 to the x minus 1 is equal to 2. Now we actually, in fact, we have to use our CAS calculator to find this. What we will see with our, if you remember even from last year, and we'll do it again in our next couple of exercises, there's my base, so I can do log base 3 of 2 is equal to x minus 1. X is equal to 1 plus log base 3, 2. Now we'll get to that process a little bit further down the track, but you may have remembered it from year 11. Or we just use our CAS in reality. State the domain and range, forgot that last time. So the domain is R. What about my range? I'm looking at that solid blue line. It's from +2 down to -infinity. So from -infinity to +2. Don't write them the other way around. Notice how I didn't really talk about the fact that it was a 3 to the x instead of a 2 to the x. All it does is change the steepness. We've plotted our points, so we treat them the same. All right. What about the next one here? Last example. 6 times 2 to the x minus 1 minus 12. Okay, so again, dilation factor. So it's 6 times bigger, so it's 6 times from the x-axis. So again, it's really just going to stretch. All we really need to focus on is the 1 unit to the right and 12 units down. So I'm going to put my horizontal asymptote up high. Sorry, my horizontal axis. Probably shouldn't have put it in the middle. Let's undo that. Let's take that line there. So there's my y-axis, there's my x-axis. So my standard graph is going through there and it's going up like that. So it's going to go 1 unit across, which is there, and 12 units down. So can I treat everything as 2s? 2, 4, 6, not really. So I'm just going to pick a point. My horizontal asymptote, we know now has to go at y equals negative 12. Let's get x and y intercepts. So the y-intercept, x equal to 0, I'll get y is equal to 6 times 2 to the 0 minus 1 minus 12. 6 times 2 to the minus 1 minus 12, which is just 6 times a half, which is negative 9. So it's going to be, well, if that's negative 12, negative 9 might be up here somewhere. Who knows? And if we get my x-intercept, I'll put y is equal to 0. I get 0 is equal to 6 times 2 to the x minus 1 minus 12. 12 divided by 6, 2 to the x minus 1. So I get 2 is equal to 2 to the x minus 1. And again, because the bases are the same, I can equate the powers. 1 is equal to x minus 1, so x is equal to 2. So if I make that a 2 there, I can get my graph to go something like that. So 2, 0, 0, negative 9. I've labelled my asymptote. And then it says the domain and range. So the domain is again R. The range, lowest value is negative 12, but not including, up to infinity. Okay, get to it.